All right, good afternoon and welcome to this week's Iowa Learning Farms Conservation webinar. I'm Matt Helmers with Iowa State University and ISU Extension and Outreach. Happy to be able to host the webinar again this week after being gone last week. Actually was in Nebraska at this time last week in the Sandhills. So if you haven't been there, I'm going to put a plug in that you need to go visit the Nebraska Sandhills. Um, so we are really fortunate to have Dr. Karina Schoengold with us. She is a professor in ag economics and associate director of the Nebraska Water Center at the University of Nebraska-Lincoln. She's going to talk to us today about optimizing precision conservation with on-farm precision experiment data, the role of crop insurance, and spatially variable profit. So I think as we think about agriculture right now and some of the margins, thinking about where we're seeing profit in individual fields or not is super important, maybe more important than ever. Um, as always, if you have questions, please type those in the chat box and we'll get those to Dr. Schoengold at the end of the talk. With that, Karina, the virtual floor is all yours.
Excellent. Well, thank you. I really appreciate the chance to talk about this work. Now, the title, I'm Karina Schoengold from the University of Nebraska. The title, I recognize it's a bit of a mouthful. Let me go through some of the pieces. Optimizing, so when we're looking at precision conservation, and with that, we are referring to conservation, partial field conservation, so enrolling part of a field into conservation land cover, but doing so in a way that that recognizes and looks at the profitability and strategically placing that within a field to improve profitability. On-farm precision experiment data, I'll talk a bit about in a minute, but that's an approach that's used to collect large amounts of data from within a field to understand that variability within a field. And so we're going to use that data to look at conservation approaches, recognizing crop insurance. I'm sure everyone on this call, no one needs an explanation of what crop insurance is, but spatially variable profit, that piece, we recognize that variability within the field. So again, a bit of a mouthful, but a lot of pieces here to bring into this. So first, a little bit, I want to acknowledge my co-authors. This work was part of Badri Kanal's dissertation research at the University of Nebraska. In addition to this work, he did some research related to the STRIPS program at Iowa State, which is how we became interested in this, and so that's been a great collaborative effort. Taro Miano, my colleague at the University of Nebraska, and also Dr. David Bullock at the University of Illinois, Urbana-Champaign. He runs the Data Intensive Farm Management Program at UIUC, and the data that we use is coming from this program. And so we really, we're using very detailed data for this work. So a little bit of background on why I think this piece is relevant and important right now. We know, historically agriculture there's been a need for agriculture to provide food. More recently, we've seen a use of feedstocks for fuel, as well as the need to recognize impacts on ecosystem services, things like water quality, erosion, and habitat, and recognizing that these are both some of these pieces, some of these ecosystem services are private benefits, such as improving or protecting soil health and productivity, but many are public benefits, things like water quality and erosion and other benefits. And this is part of the motivation for the policies such as the conservation title in the Farm Bill, which has things like the Conservation Reserve Program. There have been a lot of names and the names often change, even if the ideas don't change that much. Currently, there's a lot of focus on regenerative agriculture as a area that needs to be evolving for improving agricultural production and reducing environmental impacts. One piece that I like about the generally accepted definition of regenerative agriculture, again, there are multiple definitions, but overwhelmingly they do recognize the need for innovative technology. So this is not a approach or a desire to go back to agriculture 100 years ago. This is an approach that let's use technology and the resources available to make agricultural systems operate more efficiently and while recognizing impacts. This is relevant, very relevant now as we see increased use of things like on-farm monitoring, sensors, GPS. So those listening are, I'm sure, are very familiar with the widespread use of a lot of these technologies. They're certainly not everywhere yet, but the availability is increasing. This is not something that's just available on a agronomist test plot or on a test field at a university research lab. A lot of these technologies are widely available. In fact, a recent study, the USDA Economic Research Service looked at the adoption of precision agricultural technologies by type of technology and farm type. And this is data from 2023. So one outlier here that's clear is small family farms, which are farms which have a gross cash farm income of less than $350,000, have significantly lower rates of adoption of all of these technologies than other groups. But for mid-size or larger farms, two types of technologies I want to mention because they're relevant to our work today. Yield monitors, which are used by more than half of those mid or larger size farms, 55 or 68%, and that's the portion on the left. The other piece that's relevant for this work is the use of variable rate technologies, and so systems that can provide more efficient input usage depending on the variability within a field. And those as well, have in 2023 adoption rates over 30%. So again, this is not something that is just a sort of theoretical concept. These are technologies that actually are being adopted on the ground. So for this particular project, what we want to evaluate is whether this precision farming data, so this yield monitor data, these precision systems, can that data be integrated with conservation planning to improve profitability? And we also want to look at whether crop insurance premiums are affected in a way that is economically relevant and important with this decision. So to do this, we are going to use the case study of a prairie strip. I think probably those of this, I would guess that with this audience, prairie strips are very familiar concept. Prairie strips, the team at Iowa State has been working to evaluate the impact of prairie strips within crop fields for over 15 years now and has lots of data and research that has analyzed those impacts and found ecological benefits, agronomic benefits, economic benefits. And some of this work has looked both at those private benefits, so what are the benefits for the farmer of putting a prairie strip in a field, and public benefits. And both have been found to be significant in recent work. So we use prairie strips in this case study to evaluate precision conservation. So a little bit on our approach. So we have 3 steps to our approach for the analysis that I'll be presenting. The first is that we use on-farm precision experiment data. This is highly disaggregated data that provides a lot of information across that about that within field variability. And with the on-farm precision experiments, there are different cells for different levels of inputs. And using that data, we estimate a production function at the cell level. So this is, there's over 1,800 cells within this field. These are very small parts of the field. And we use that information to estimate the profit maximizing levels of inputs. And in this case, this particular field, we're looking at seed and nitrogen rates. So those are the two inputs that are varied. Using those, we look at what level of inputs would maximize profits. What is the predicted yield with that amount of input? What is the predicted profit? And then we aggregate those across a strip. Sorry, I was just looking at, and then I just noticed some things coming up in the chat. I'll look at questions later. And then the last step is using this strip variability. We look at how one would, using smart or data in provided information, use that to determine the most profitable set of strips for a prairie strip or for conservation land cover. And in that, we incorporate the expected corn profit. This is a cornfield, CRP payments, and crop insurance premiums. So this is the on-farm precision experiment where we use the data for this particular, for this study. This is really a proof of concept. And so we don't want to imply that the results are going to be the same across different fields or different, and so this is something, an example of how we can use this kind of information to evaluate precision conservation profitability. So this particular field, it's in corn. It's corn data from 2019. It's in Effingham County, Illinois. It's divided into about 1,800 what are referred to as cells, and there's varying seed rates and nitrogen rates. The resulting yields that you see here are the actual observed yields, which are not, because of the fact that the inputs are varied based on experimental design, these are not the optimal yields, or these are not the yields that one would predict from managing this field for the highest level of profitability. So it provides information but shouldn't be taken as the most profitable yield. For example, if a section has a low seed rate and a low nitrogen rate, we will likely observe a low yield as well. So we use this information to estimate these production functions for each one of these over 1,800 cells. The seed rates that were used in this particular experiment were range from 25,000 to 43,000 seeds per acre. Nitrogen fertilizer rates ranged between 108 and 249 pounds per acre. The observed yield ranged from 50 to 203 bushels per acre, but again, with the caveat that I mentioned before, that often that observed yield is much lower than what we would expect from a profit-oriented approach. And so we use that data to estimate these production functions. We looked at different functional forms that related the seed rate, the nitrogen rate, and constant with the observed yield to try to get a best fit. Again, we looked at 15 different functional forms. The best fit among those was we chose based on the overall fit and the predicted yield, which in this case, we found a predicted yield from 117 to 221 bushels per acre, which is seemed reasonable given the history and the information on this particular field. Now to look at profitability, the prices that we use are based on the University of Illinois costs and returns data from 2019. So the prices are $3.20 per thousand seeds, 38 cents per pound of nitrogen, and $4.50 per bushel of corn. And then since we have those profits, yields, and costs estimated at the cell level, we aggregate those since we're going to be making decisions at a strip for a single strip. We aggregate those. We take a weighted average across all of the cells in each strip. And from that, we get optimize the average yield, the average profit, and the average costs by strip for this field. And again, we do that because with the precision system, we can apply inputs as a variable rate across that strip for different cells. But for the decision to keep it a strip, or for the decision for a particular strip, it's either going to be fully put into conservation or fully in corn production. Notably, you can see from this chart that there's a very high correlation between A and C, which are the optimized yield and optimized profits. Costs is not quite as highly correlated, and this is because there are some areas that are high profit and also use a lot of inputs. Some areas are high profit because they're relatively efficient, may use fewer inputs, but still get a relatively good yield. So again, that correlation becomes important between yield and profit. Now, the last piece of this is going to be looking at the profitability of different outcomes. So the extreme cases are either full field in corn, fully planted, or the full field in the Conservation Reserve Program. We use estimated costs. Again, these are based on what we calculate for the full field in corn is a expected profit of $157.6 per acre if we ignore insurance. If we include insurance, it's about, and this is insurance premium, without any indemnity, it's about $119 per acre. This includes an estimate for other costs of $386 per acre. And this was also from the University of Illinois costs and returns study. CRP is the return from that is based on the CRP rental rate in Effingham County in 2019 and the establishment and upkeep costs for a prairie strip. And so that's $134 per acre of an estimate. Now it's a little more complicated when we look at partial field, so precision conservation. And what we do is we look, there's 31 strips within this field. We look at every possible number of strips for a partial field retirement, starting with what if we only retire one strip, what if we retire 2, 3, 4, all the way up to 30. We do require that if there multiple strips are put into conservation, they have to be adjacent to each other. And this is done because of the feasibility of just managing a system and managing what the system looks like. And again, I think consistent with some of the research from prairie strips, it suggests that having a prairie strip within a field is beneficial, and it's more important to have a prairie strip than having a separate prairie or multiple prairie strips. And so, for example, if we look at retiring 2 strips, we allow strip 2 and strip 3 to be retired together, but not strip 2 and strip 6. And we do this all the way up to 31 or 30 strips. 31 is the full field. There's a few other adjustments we make when we do partial field conservation, and these that are not relevant for full field decisions. One is to reduce the expected yield if there's any new field edges. We had some suggestions that there's some loss of yield due to edge effects, and so we reflect this by putting a slightly for the strips adjacent to that new for the sections adjacent to that new the conservation strip, adjust those yields down a little bit. We also increase other costs to reflect slightly higher or somewhat higher machinery costs. And so to reflect that, particularly the cost of moving equipment between fields, if there's fewer acres to spread those costs over, then we'll adjust. We make an adjustment. The last thing that we adjust is crop insurance. And so here, we are trying to compare apples to apples with coverage rates, which is challenging because if yields change, that can change premiums. And so it's a bit of a thought experiment of how we go about this. First, we set the initial crop insurance premiums at 85% of the full field yield. And so 85% coverage. And then instead of adjusting the yield coverage, we adjust the rate. And so this keeps the yield that's covered constant, but adjusts the rate accordingly. So here's an example to go through. So for example, if the yield on the entire field when it's fully in corn is 200 bushels per acre, the yield coverage would be 170 bushels per acre, or 85% of 200. But now if part of the field is taken out of production and put into a prairie strip, and the updated yield increases to 220 bushels per acre, then, well, if we covered 85% of 220, that's covering a higher yield guarantee. And so that's really not comparing apples to apples. So to try to keep the coverage at the same level, we figure out an effective coverage rate. So 170 divided by 220, which is our new yield, is 77.3%. So this reflects a coverage rate of 77.3%. Now, of course, anyone who knows about crop insurance knows that you can't go and buy coverage for 77.3%. And so we estimate what the costs would be for that based on interpolating between those coverage rates that are available, or in this case would be between 75 and 80%. We look at we take those costs and then predict what the costs would be for that 77.3%. So now results. And I'll admit there's a lot going on in this chart. So I'll walk through all of this. First, along the x-axis is the number of retiring strips. So moving from the full field in corn production to the full field in conservation reserve program. The top line here is the results if we completely ignore insurance. And so we only look at the profitability from corn production as we take parts of the field out of production and put it into retirement. And one other small piece along the top is which strips are actually retired. So for example, if one strip is retired, it's strip 26. If it's two strips, it's 26 and 27. And so we can see how the size of, and with a portion of the field, how that changes as additional land is put into a conservation strip, a prairie strip. So now the two lower lines reflect the inclusion of insurance premiums. And there are two lines because one of them, we want to compare a, say, more naive view of insurance, which would, based on an estimate if insurance premiums were the same after land was put into conservation, with the updating that we do, which reflects a generally a lower premium as less profitable land is taken out of production. And that is the top line of those two is the one that reflects those cost reductions. And the bottom line is based on keeping costs the same. And so those only, and again, and one other piece with this, we're only including the insurance premium. We are not including an insurance indemnity, in part because indemnities are quite, they're variable year to year, they're infrequent. And so we would need to have a long series of history on this field to really get a sense of what that indemnity might be. So this provides a little bit of background on what we see in this chart, a little bit more on the implications of this. So first, I want to focus on what is the most profitable outcome. The highest point in terms of profit per acre is more profitable than either fully in corn, fully in production, or fully in conservation. And that's either $172, $152, or $147 per acre. And this is at either 10 or 11 strips. It's a little bit larger when we include that insurance savings. And so that pushes the profit maximizing conservation strip slightly larger. Although I'll note that, in this, it's not a very large change. It's one more strip. However, another piece that is more significant is that the gains from from prairie strips or from partial precision conservation are higher when we include those insurance costs relevant to ignoring those. And we see in this either gains of $32 or $28 per acre versus $14 per acre relevant to the full field and corn outcomes. And so this reflects that the magnitude of that benefit is impacted by that insurance coverage. Now, we also recognize that this is 10 or 11 strips. This is about 1/3 of the field, and a lot of the literature on prairie strips has suggested that they should be a smaller portion of the field. And so if the prairie strip is, say, capped at 20 or 25%, that puts the optimal prairie strip at 7 strips. In this case, it's strips 24 to 30, and which is still significantly more profitable than the full field in corn, especially when we incorporate the insurance savings from doing so. So first, a bit of a recap on some of the questions that we wanted to address. First, can this precision data be integrated with conservation planning? We find evidence that yes, by smart planning for conservation, there are sizable benefits for profitability. And so really, again, this is a proof of concept from one field, but shows the potential for using this highly disaggregated data to improve conservation planning. This, if someone was going to actually implement this, it would, of course, need multiple years of data to really make informed decisions about how to plan for and how much conservation land cover to put in, and where to put that. However, we do note that one of the things that we found from prior literature is that the relative rankings of profitability within a field change a lot less than the magnitude of profitability. So the portions of the field that are consistently more profitable tend to stay the same year to year, much more than overall bottom lines. The impact of crop insurance is the magnitude is significant in terms of the cost savings. It shows it increases the relative benefits of putting in conservation land cover relative to ignoring crop insurance. However, it does not significantly change the optimal placement for that prairie strip. So the take-home messages, just a couple of final points. We do, again, this is proof of concept from one field, but I think really shows that this precision data can help provide win-wins for conservation and profitability. Variable rate systems and yield monitoring are really helping to make this feasible across a broader group of farms and users than would have been the case, a few decades ago. And so this greater incorporation of data on farm data is really useful for moving this forward. Crop insurance premiums, we do find, again, evidence that premium, if we ignore it, it underestimates the magnitude of precision conservation benefits when those are included. And so, incorporating that and thinking about what that savings is important. It's, though, unlikely to significantly change which portion of the field is best to retire. So with that, I really appreciate the time. I'm happy to take questions and look forward to hearing from everyone in the group.
All right. Thanks, Karina. Let's go through those logistical slides and then
Actually, I forgot one item.
All right.
One item I forgot to mention. I mentioned this to Matt before we started. We're going to have a departmental newsletter that's talking about some of this work that's coming out in the next couple of weeks, and I'll share that with the Iowa Learning Farms community when that's published to provide some additional information on this.
All right. Okay. Thank you. Yeah, I'm glad you remembered that. It already you told me that you're going to do that. I almost forgot. So, all right, let's go to the logistical slides. And the first one should be if you need a CCA CEU. I don't know if you can advance the slides.
Can you? Oh, yeah. I was wondering if.
Yeah.
Okay.
There we go. If you watch this webinar live and want to earn a CCA CEU, please email Elena Whitaker, ALENAW @iastate.edu by 5 o'clock today. Include your name, the name you entered to watch the webinar, and your CCA number. Again, ALENAW @iastate.edu. We can go to the next slide. Next one, if you can go to the next one. Yep.
Yeah.
Okay, if you watch this webinar live and are willing to fill out a voluntary survey, demographic survey, we'd greatly appreciate it. You can scan that QR code or go to iowalearningfarms.org/survey. If you've done one for 2025 webinars, thank you very much. You only have to do it once. If you haven't and are willing to do it, we'd greatly appreciate it. We can go to the next slide. Should be putting a plug in for Mason Burkhart. That's with the Center for Agricultural Law and Taxation. It's going to talk about estate and succession planning for the farm. So another important topic. And I think then one last slide that should be, if you watch this, all the webinars are archived. You can go to iowalearningfarms.org/webinars or go to the YouTube page that's specifically on webinars. And you can watch to your heart's delight, watch others. Feel free to forward that link to others that may have missed the presentation today. So we do have a couple questions in there. The first one was, were there any costs deducted from the CRP rental rate, for example, establishment cost, weed, brush control, mid-contract management?
Yes, the costs. So we take, I think we based those from some reports from Iowa State on the cost of prairie strips, and they're in the range of around $30 an acre for establishment costs. And so we take the actual CRP rental rate for that county is about $160 something, and so we take that $30 off of it, and that's where we get that $134 is after taking that $30 off.
Yep. Next one, are the retired strips always consecutive, or is that just in this example?
Oh, that's a good question.
Yep.
We we impose that as
Okay.
a requirement for the analysis because it's what we were trying to put look at a system that was feasible from management perspective, um, and we heard from for a number of for management it's going to be easier to manage a single strip to avoid it, and then um, so in our results they are. You could do something like this and not put that requirement in if you had some flexibility about where you wanted to put in strips or you wanted multiple strips in a field. That could be changed. But yeah, our results are based just for ease of implementation. We do require that with.
Yep.
And the reality, if you look at the yield data and the profitability data from this particular field, even if we didn't require it, the sections of the field are relatively more or less profitable. So I I would, we didn't run the analysis, but I think at least for relative, a lot of those, if we were looking at the best, say the best three strips to retire and didn't require that they were together, I think they would probably be adjacent anyway.
Yep. Yep. That might be a little bit dependent upon this field. And
Yeah,
yeah,
absolutely.
yeah,
That is
yeah,
that's a field dependent
yeah.
result.
And that kind of brings up the next question that certainly I wondered as well. Are there plans to look at this on more sites and fields?
Yes.
Cool.
My colleague, Dr. Miano, is working on that as well. So that the program out of the University of Illinois has been doing this type of data intensive monitoring of fields for a number of years in different locations and different crops, different locations. And so he's been doing some work to try to bring those together and look at a more thorough analysis across more fields, more locations. We don't have any results on that yet, but but yes, there is
Okay.
some work, and we thought this would be a useful more as a proof of concept of how this data can be used to inform conservation planning.
Yeah. Great. Um, you showed considerable uncertainty in predicted yield. This individual was wondering how was that uncertainty carried through to calculations on profitability?
Uh, that's a good question. We do not include, so we take the point estimates of predicted yield and then the what the profit maximizing input uses to achieve those yields, and then estimates on and then we calculate profitability based on those costs from the cost and return study. We don't incorporate this does not incorporate any uncertainty. That is another piece that I think is an important piece for an extension of this, is to evaluate what how uncertain those returns are. And that's another piece that more years of data would be helpful for getting some estimates about that uncertainty. But these particular results don't have any uncertainty. No.
Okay, interesting. Um, one person asked, hypothetically, wouldn't the increases in profit be expected to be much higher in a real world scenario? They're wondering, wouldn't the difference between retiring consistently underperforming portions of the farm and continuing to farm the higher producing areas instead of the random rate adjustments from this study? It
Um,
was It was,
Okay. I just pulled it up in chat
yeah,
because
yeah.
I
It
think
might
I
be
needed to
easier for
actually
you
see
to
it.
read it than me to try to read it to
Uh,
you. Yeah.
so we're not randomly retiring. We are specifically retiring those portions that are least profitable. And so, in the way the approach that we use with this precision data from the field, and so we are, so we are very, explicitly trying to target the areas that are least profitable, as opposed to just randomly setting the strip somewhere in the field. Um, we're trying to do so to have the highest level of profits. And so I'm not, I guess I'm not sure how that the increases in profit would be that much higher. Again, this is one field and 1 year. So we recognize that the magnitude is going to vary across a year with different input prices or different output prices. The magnitudes will differ, but we do, again, it's not random. We are putting that conservation land cover in the place that gives the highest profit with the approach that we're doing. So I'm not sure if that fully answers the question, but I'm
Okay. There was maybe a last one here. There was the question: are the random rates used to determine the most profitable seed and N rates?
Oh, okay. Maybe that was
Yeah,
the random rate piece
yeah.
that um, the person, the no, the random rates are used to calculate a production function. So we calculate a production function for each cell based on the observed yield and the observed random rates. And so, yes, so we calculate for each cell, we calculate a relationship between observed yield and then nitrogen and seed inputs. And then we use that function to predict what, how much nitrogen in seed inputs would we use if we wanted to maximize profitability. And so often those are not the same as what was put in with the experiment. The experiment was designed to try to get more information, but the actual inputs that are used to calculate profit are not from those random rates. They're based on trying to estimate what would maximize profits at each point.
Okay.
I hope that clarifies.
Yeah, I think that does. So
Okay.
again, I put in the chat box if you need a CCA CEU, please email Elena Whitaker. Uh, her email is alenaw@iastate.edu. Include your name, the name you entered to watch the webinar, and your CCA number. With that, Karina, thank you so very much for your presentation and for this work. Hopefully, we can get you or someone from your team back when you uh, add other fields. I'm really curious about this. Personally, I'm curious to try to look at some of this profitability on my family's farm back home as well, and thinking about perhaps placing prairie strips. So, thank you again, and any last comments from you?
No, I really appreciate the chance to present this, and like I mentioned, I'll send along the write up when we have that, and I would appreciate any comments or questions. I'm happy. Please, I think my email is available, so please send that along. Please send those along.
All right,
Thanks.
great. And yeah, we'll try to make sure that gets up on the Our Learning Farms blog so people will be notified when that newsletter information is available.
Okay. All right. Well,
All right.
thank you very much.
Yeah.